Today's lesson will describe how to build reduction half-reaction tables. An experiment that you'll be performing later this week involves observing a series of reactions. A set of metals will be tested with different metal ion solutions to see if the reactions are spontaneous. In the table here, copper, lead, zinc, and silver were tested. On the table, you can see that silver ions react with copper metal, lead metal, and zinc metal, while zinc ions don't react with any of the metals tested. Based on the reactivity results, the metals and metal ions can be ranked from most to least reactive. The data observed may be used to build a reduction half-reaction table. Because silver ions are the most reactive, they are written first. Because zinc ions are the least reactive, their reduction half-reactions are written on the bottom. Alternatively, a table of oxidation half-reactions may be built. Here the oxidation half-reactions are written from strongest to weakest. Because zinc metal was the most reactive metal, it goes on the top here. Because silver metal is the least reactive metal, it goes on the bottom. A couple of trends are always observed in these tables. Metal ions are the oxidizing agents, and metal atoms are reducing agents. In tables of reduction half-reactions, the strongest oxidizing agent will always be on the top left, and the strongest reducing agent is always at the bottom right. This leads to a rule of redox spontaneity. In a table of relative strengths of oxidizing agents and reducing agents, if the oxidizing agent is above the reducing agent, the reaction is spontaneous. If the oxidizing agent is below the reducing agent, the reaction is non-spontaneous. This example with imaginary metals and metal ions shows how the rules can be applied to any set of metals and ions. Again, the species that are oxidizing agents will be the metal ions, and the species that are reducing agents are the solid metals. We can use the experimental data to determine the trends in reactivity. The trends can be used to build a table of reduction half-reactions. If the table is built properly, it can then in turn be used to predict spontaneity of other metals and metal ions. Please complete the October 10th quiz.